joining us. We welcome you to our FDP on AI in medical imaging and diagnostics. So, Professor Sipanna Saha is an associate professor in the Department of Computer Science and Engineering at IIT. She received her MTech and PhD degree from ISI Kolkata in 2005 and 11 respectively. Her current research interests include multimodal information processing, natural language processing, machine learning, information extraction, text mining, bioinformatics, and multi-objective optimization. She has authored and co-authored more than 400 papers. She is also author of book published by Springer. Her H index is 47 and the total citation count of her papers is over 11,000. She is a fellow of IET and senior member of IEEE. She is also the recipient of Rasi Roy Memorial Gold Medal from ISI Kolkata for outstanding performance during her MTech. She is the recipient of Google India Women in Engineering Award, Nasi Young Scientist Platinum Jubilee Award, BARD Award, IEI Young Engineers Award, SCRB Women in Excellence Award, SCRB Early Career Research Award for the year 2018. She is also the recipient of Duo India Fellowship 2020 Fellowship by Indo-US. She was the recipient of EMMA Fellowship of the European Union to work as a postdoctoral research fellow at Heidelberg University, Germany from 2009 to 2010. She had visited several universities like University of Caen, France, University of Mainz, Germany, University of Kyoto, Japan. She is also a visiting professor there. She won Best Paper Awards in several conferences like Clinical NLP Workshop, Indicon, and ICA CCI 2012. So with this now, I request ma'am, please start the session. Over to you, ma'am.
Yeah, so thank you very much for the invitation. So today I am going to discuss about some of our recent research works on LLMs and VLMs in healthcare domain. Okay, so I'll be discussing about how we are using the large language models and the visual language models in solving some problems of the healthcare domain. So I am Dr. Sriparna Saha, currently an associate professor in the Department of Computer Science and Engineering, IIT Patna. And my web page is www.iitp.ac.in/Sriparna. And my email address is sriparna@iitp.ac.in. And so let me start with an introduction of large language model. So you know that large language models are basically language models which has a very good understanding of the English. So large language models are trained on enormous amount of text present on the web, and a large language model can use the knowledge it has gathered during training to make predictions and create new content. So it has a very good understanding of the English language, Spanish language, and all the high resource languages, and that's why it generate very good English, and it can also write essays and generate English, and they also have very good question answering capabilities. And the most famous LLMs available out there are GPT-3 of OpenAI, ChatGPT by OpenAI, Claude by the Anthropic. And what are the large language models? So you can easily compare, like a 13-year-old human being perhaps has seen less than 100 million words in his or her lifespan, but BERT, which is introduced in 2018, has seen in its training data there are 3 billion tokens or the 3 billion words. Roberta, which is introduced in 2019, has seen in its training data 30 billion words. And GPT-3, which is introduced in 2020, has seen in its training data 200 billion words. So that's why these models are called the large language models. So if you can compare the training data of these models, you can easily understand why these models are called the large. So now this is the history of the generative AI models. So you can see that initially it all started with the generating the images and the videos. So we have the generative adversarial networks or the variational autoencoders. So it is all about starting generation of the fake images and the fake images or the fake videos, GANs and the variational autoencoders. In 2014 or in 2015, it all started with the generation of the fake images and the fake videos. Basically, the computer vision community developed the GAN. There is a discriminator and there is a generator. Generator was generating the images, and the discriminator was trying to discriminate between the images and the fake images and the original images. So the generator and the discriminator was becoming very popular. And then in 2017, the transformer architecture was proposed. So transformer architecture can easily understand the long context. So you know that in NLP, long context was a very big problem, because there are many sentences with a long context, like a chef who has started his own business in Delhi has now started a chef who was working in Delhi has now started his own business in Patna. If you see this kind of statement, then it is very difficult to understand the correlate which word maps to which word, and this in order to in order to resolve this correlation problem, the transformer is very popular. So with the introduction of transformer network, the in natural language processing community, it was a very helpful for the natural language processing community to understand the meaning of the sentences. And starting from 2018, the transformer models have started developing, and these are some billion parameters large language models which are trained using huge number of text data. And there are many GPT models available. And in from 2022 onwards, there are many diffusion models. So these diffusion models are taking some text description, and they are generating the images. So this is the journey at a whole of the generative AI models. So we have initially the text to text, the generation of the fake videos, the generation of the fake images. Then we have the transformer models. Then we have the billion parameter large language models. And then we also have the diffusion models. So the diffusion models are basically generating the images from the text. So there are many LLMs which are available. Like if you see that almost all the companies are now focusing on developing their own LLMs. So starting from the Google, and almost all the Meta, OpenAI, almost all the companies are putting their efforts in developing their own LLMs. So you can see that Google has developed T5, MT5, Plan, Palm. So all go Bard. So Google has developed almost all the LLMs. Similarly, you know that OpenAI has developed all the GPT series like ChatGPT, GPT-4. Almost all the this GPT models are developed by the OpenAI. So this way, all the companies are focusing on developing their own LLMs. And why large language models are so popularly used? Because large language models are few shot learners. So if you can simply give a few examples of the large language models, and already they are trained on a huge amount of data. And now if you can give a few examples, they can easily learn from those few examples. So because they are trained on a large amount of data, so now after seeing a few examples, they can easily learn from those few examples. So large language models can be viewed as few-shot learners in the sense that they can generalize to new tasks and domains with only a few examples. This is because large language models are trained on a large corpus of text data, which provides them with a general understanding of the structure and patterns of language. When faced with a new task of domain, a language model can use this general understanding of language to learn from just a few examples. So there is a task called the in-context learning. So in-context learning means that already they are trained on a huge number of data. So when you are giving a small amount of data to them, they simply learn from this new data. So in-context learning is a type of learning in which a large language model learns to accomplish a task after seeing only a few examples. like already, like for a human being already gathered knowledge throughout their lifetime. We have already gathered knowledge from our lifetime from various tasks. Like when you will ask us to solve a new task, you only have to give us few examples of the new task, and from those few examples we can easily start solving the new task. So this is basically called the in context learning. So in context learning is a type of learning in which we can easily start solving a new task after seeing few examples of the task. And providing instruction to a LLM is basically called the prompting. So in general, in basically natural language, we can provide the instruction to a LLM, and this is called the prompting. So you know that, and this is not in any programming language. This is in very much natural language. In natural language, we can basically give a instruction to a LLM that you have to perform a particular task. And prompts can be simple as a question, or it can be as complex as multiple paragraphs. And in the prompts we need to only mention what are the steps we need to perform to solve a particular task. So prompts can be as simple as a question, or prompts can be multiple paragraphs as well. So people are researching on how to give a efficiently a particular prompt. Like when you are asking a LLM to solve a particular task, there are different ways of giving the instructions. So what are the different ways of giving the instructions that researchers are working out? So they are working out how efficiently we can give instructions to LLM. So it can be only one line instruction, or it could be multiple lines of instructions. So the prompt engineering is now a research domain or a research direction where researchers are working on how efficiently we can give instruction to LLM. So it involves designing and refining prompts or input sequences that guide the model to produce more accurate and relevant outputs. So now let me show you some of the popular generative AI tools which we are using in our day-to-day life. And afterwards, I will be showing applications of generative AI in the healthcare domain that we are doing in our lab. So, for text generation and summarization, some popular large language models are Gemini and the Claude. So, like if you have to generate an essay, or if you have to generate a summary, like if you have a long text and you want to generate a summary from the long text, or suppose you want to write an essay on a particular topic, so you need some LLMs. So, ChatGPT or the Claude or the Gemini, so these are the some of the large language models which are becoming very popular for text generation and the summarization. So modern LLMs like ChatGPT from OpenAI, Gemini from Google, Claude from Anthropic, and open source models like Llama from Meta. So they exhibit exceptional instruction following capabilities and are widely used for open-ended text generation and summarization kind of a task. So like here you can see that we can give a prompt like write a 60-word essay on the impact of AI in social sciences, and then that you can select a particular LLM like Claude or the ChatGPT, or or any other LLM, and it will simply give you a essay on the particular topic. Or you can simply give a long paragraph and you can ask it to summarize the long paragraph, and it will simply summarize the long paragraph and will provide the summary. Now we can also upload a PDF document and then we can play with the PDF document. So there are many tools like ChatGPT, Claude, and the Adobe AI Assistant which can enable us to play with the PDF document. Okay, so they can help us in play with the PDF document. So we can upload a PDF document and we can ask any question related to the PDF document. So Adobe AI Assistant, Claude, ChatGPT, these are the some of the LLMs which can interact with the PDF documents directly. So like here, for example, we have given a PDF student's resume as an input to ChatGPT, and then we can ask, what are the, can you tell me with some the options for the ideal career for this person with proper justification. So then this chat GPT will analyze all the possible career options for this particular person, and then it will give us all possible career options. So this way it will give us all the possible career options. So then there are many tools like Tableau and the Visually, which will provide AI-based solution for users to gain insights from data using a simple natural language query. So like there are many tools like Tableau or the Visually, which can also help in writing the program. Okay, suppose you want to get some insight from the data. So you want to understand the some insights from the data, and you want to write a small Python code from the data. So this Tableau and the Visually can help you in writing a small Python code from the data. So similar capabilities also exist in the models like GPT-4o and the Claude. So here you can give a prompt, and based on the prompt, they can also help you in writing a small Python code to analyze the data. So like for example, I want to analyze some data which is in-house. Like there is a data which is in-house, and we can ask the Visually analysis of a data using Visually, where we find the most common words in the data set. So there is a data set, and we can ask it to analyze, find out the most common words in the data set. And the Visually is a tool, so Visually can easily find out the most common words in the data set. So Visually can simply write a Python script, and then it can provide us the Python script and also the word clouds. So basically this way Visually can not only provide us the Python script, but Visually can also give us the word clouds corresponding to the this particular Python script. So this way you know the Visually is a particular tool which can provide us all the outputs. Now there are some research discovery websites like Semantic Scholar, Connected Papers, MirrorThing.ai. They simply do the tedious process of literature survey and help in finding out the related works with respect to a particular domain or existing research paper more easily. So suppose you want to do some related research. So you want to search, you want to start working on a particular area, particular area, you want to do research in a particular area, and you want to know, you really want to know that what are the other papers which are available in the particular area. So then there are some websites like Semantic Scholar, Current Papers, MirrorThing.ai, which can help us in searching for the related papers. So basically, you know that there are tools like current papers where we can search with a particular topic and we can get all the related papers. Okay, so all the related papers we can easily get, and not only it will give us all the related papers, but it will also give us a graph-like structure. So a graph-like structure like this it will give. Here the graph nodes correspond to the paper, and the node density is also varying. So node density is varying means if the papers are having high density means the papers are having more citations, and if the papers are having less citations means the papers are having papers are having if the density is more means the papers are having more citations, then the density is less means papers are having less citations. This way here it is also forming a graph like structure, and now we can easily select a subgraph from this graph. Okay, and then we can do perform a literature survey. So basically this way this current papers.ai and the MirrorThing.ai and the Semantic Scholar, they can help us in doing a thorough literature survey. Now there are some human image interaction, like suppose you are uploading image and then you want to ask some question related to the image. So there are some visual language models like GPT-4o from OpenAI, Google Gemini, and the Claude models with open source model like Lava, Instablip. They can also take some images as the input, and then you can ask some question from the images, and they can simply answer the images, answer the questions from the images. So here users can upload an image and ask model questions based on it. Such models find applications in various social science application domains like sociology for analyzing media content, history to know more about historical images, psychology for emotion analysis, and many more. So this Gemini or the Claude or the GPT-4o, so these are the models which are useful for interacting with the images. So like here you can see that we have uploaded an image. What is unusual about the image? Can you explain this to a 5-year-old kid? So in the image, there is a man standing on top of a yellow car, which is unusual because people typically do not stand on top of cars, especially while they are driving. It is also uncommon to see a person ironing clothes on top of a car, as ironing is usually done indoors or in a designated area. This scene is quite unique and might be considered humorous or intriguing to a 5-year-old kid. It is important to explain this that this is not a typical situation and that people should not attempt to stand on top of cars or iron clothes in such a manner. Now introduce me this painting in detail. This painting depicts a young girl with a pearl earring, also known as the girl with the pearl earring or the girl with a pearl earring. She is wearing a blue dress and has a pearl earring on her left ear. Her hair is pulled back into a bun and she is looking directly at the viewer. This painting is a famous work of art by Dutch painter Johannes Vermeer, created in 1665. It is considered one of the masterpieces and is widely recognized for its intricate details and realistic portrayal of the young girl's facial expression. So then we can also ask Mini GPT V2, please describe the image as detailed as possible. The image depicts a large cave with a group of people painted on the walls. The group are the people are engaged in various activities such as hunting, gathering, and riding horses. There are several horses scattered throughout the scene, with some in the foreground and others in the background. In addition to the people and horses, there are several other animals depicted in the cave, including a lion, a tiger, and dinosaurs. The cave is also adorned with various objects such as a bow and arrows, a spear, and a shield. Overall, the scene appears to be a vibrant and lively depiction of ancient life, showcasing the skills and activities of the people who lived in this cave. So now we will be talking about the diffusion models. So the diffusion models are text to image generation models. So here text is an input and the images are the output. So text to image diffusion models have taken the world by storm, generation high quality synthetic images, which are hard to differentiate for original ones. So there are many models like Day-6 from OpenAI, Flux, and Stable Diffusion are the forerunners in this domain. So you can give a image as an input, as a text as an input, a textual description as an input, and you can get some images as the output. So like you can see some output use of Day-6 for visualization of historical scenarios. Imagine a bustling 19th century marketplace in a small European town. The scene is lively with cobblestone streets lined with wooden stalls selling fruits, vegetables, textiles, and handmade goods. Townsfolk dressed in period clothing engage in conversations hanging over prices. A horse-drawn carriage passes through the market, and in the background, you can see the spire of a Gothic church rising over the quaint thatched roofed houses. The atmosphere is vibrant, capturing the essence of daily life in a historical town. So if you give this kind of description, it will generate these beautiful images of a historical village. Okay, it looks like these images are original images. So now let me show you how we are generating, so how we are applying these LLMs for solving some healthcare related problem. So first of all, I will be talking about this Clip Central. This is a this paper got accepted AAAI 2024 last year, where we have solved a particular problem of medical multimodal question summarization. So suppose when we are suffering from some medical disorders, we often, before consulting a doctor, we often write about our medical disorders in a medical forum or medical blogs, because many doctors are associated with the medical blogs or the medical forums, and they used to provide some suggestions regarding our problems. So basically, we are consulting some doctors, but as a second opinion, we often used to write about our problems in the medical forums and the medical blogs. But our questions are very long, but we are unnecessarily give too much description of our problem, and doctors do not have time to go through such a long description. So they want a concise summary of the problem. So this is called the medical question summarization. So how can we get a medical question summarization by a LLM VLM combination? So that was our task. And another challenge is that when we are writing our medical problem, maybe the common people are not aware of the many of the medical terminologies or the medical symptom names in the medical terminologies. So, but they can simply upload a image of the medical symptom, and they can upload the medical symptom in that particular portal, in the particular forum or the blog, and they can refer to the image and they can describe they describe the problem statement. So this way, this can become the multimodal in nature. So we basically proposed a novel task of multimodal medical question summarization for generating medical nuisance summaries. So our task is multimodal medical question summarization to generate medically nuisance summaries, and we proposed a new data set, a multimodal question summarization data set, to advance the research in this area. And also most of the existing metrics like blue or the rules, they are applicable for the summary, measuring the quality of the summary. But here in the medical domain, we also have to measure whether all the medical symptoms names or the terminologies are preserved or not. So we propose a new metric, MMFCM metric, to quantify how well the model captures the multimodal information in the generated summary. And we proposed a new framework, pipeline-based architecture. No pre-training is done. Only no fine tuning is done. It is simply the existing models, the already the pre-trained version of the models, fine-tuned version of the models are used in a pipeline-based architecture, which is called a Clip Central. So we use the the LLMs and the VLMs in a pipeline-based architecture to generate the final summary. So our proposed, what is about the dataset, multimodal question summarization dataset. So there was a healthcare magic dataset by Milne et al. In 2021. So this dataset was having 3015 medical clinical question and the summary pairs. So in this dataset there were 587 unique images. Okay. So that these images were broadly categorized into four categories: ENT, eye, limb, and the skin. And that images and the final summary are verified and updated by the medical expert. So this is the data set. So you can see the multimodal medical question summarization data set. So there are four categories: ENT, eye, limb, and the skin. So under ENT, these are the symptoms: eye, lip swelling, mouth ulcer, swollen tonsil. Under eye, swollen eye inflammation, itchy eyelid, eye redness. Limb, edema, hand palms, foot swelling, neck swelling, knee swelling. Skin rash, cyanosis, dry scalp, skin growth, skin irritation, skin dryness. So these are the different symptoms which are present in our data set. Now what we have done is that we executed the clip model. So we passed the image through the clip model, and we asked the clip model to extract the three most probable symptoms from the clip model. Okay, we have given the description of the question and also the image, and we passed it to the clip model, and we asked the clip model to extract the three most probable disorder name from the image. And then there is a LLM. So this LLM, large language model, it could be anything. It could be ChatGPT or any other LLM. So this LLM is given the original question, and LLM is also given the three most probable items, and LLM is asked to select the most probable disorder name from these top three most probable items. So the clip is giving the accuracy of 84%. And when we are incorporating the top three most probable disorders and the context through the LLM, the accuracy is improved to 87% in a zero shot setup. Okay, so only through clip we are getting the accuracy of 84%. But when you are also asking clip to get three most probable items, and we are asking LLM with the help of the question, we are asking LLM to identify one most probable item, then it is giving the accuracy increase to 87%. Now there is a context generation module. So we use the GPT 3.5. So the GPT 3.5 is generating the additional context. So we have used the GPT 3.5 to generate the additional context. So like for example, we use the prompt like what are the symptoms of the medical condition, what tests and procedures need to be done for the medical condition. So these are the two questions that we ask to GPT 3.5, and the GPT 3.5 is giving us the answers to these two questions. Now there is a context filtration module. We removes out of context knowledge generated by the last module and use image bind to calculate the similarity between each sentence and the image. So what we do is that we removes out the context knowledge generated by the last module, and then we know like maybe some of the extra context is basically irrelevant. So what we do is that we calculated the similarity between the image and the sentences in the context, and if the image and the sentences in the context that the similarity is greater than the threshold, then those sentences are removed from the context. We kept only those sentences in the context which are highly relevant with the images. So this is our overall pipeline. First, it is passing through the clip, the image. Clip is detecting the medical symptom present in the image. Then there is a context generation module. There is a one LLM which is extracting some extra context by using some prompts. Then there is a context filtration module. We are removing some extra context which are not similar to the image. And then finally there is a LLM which is given some prompt, write a very short and concise one-line summary of the following dialogue as a question in a healthcare forum, incorporating the relevant medical symptoms in the additional context given below. We are giving the dialogue and the additional context, and we are asking it to generate the summary. And finally, the final summary is being generated. So this is the model architecture. So these are the performances. So we compared with Llama 2, Red Pajama, Vicuna, Flan T5 and the GPT 3.5. These are the 5 LLMs we have compared with. So you can see that GPT 3.5 is giving us the highest result. So user score value of 40.9% we are achieving, and blue force score value of 18.6 we are achieving, and BART score of 92.1 we are achieving these values. So we have also proposed a new metric, because in the healthcare domain, this is very important that how many clinical facts we are able to retain. So this is very, very important. So that's why we are also, checking that originally how many symptom names are present in the original summary, original question, and how many symptoms are now present in the generated summary. So that way we have also proposed a new metric. And we have also done a human evaluation. Like few summaries are selected and those summaries are given to the doctors, and then doctors have also evaluated what is the quality of the summary, like clinical evaluation score, factual recall, omission rate. So all these scores are given by the doctors. So I hope I am audible, no?
Yes, yes, ma'am. You are audible, ma'am.
Yeah. Any question in the chat box? Yeah, yeah. So in context learning and the future learning are same. Yes. Yeah. So basically, now in the future work, so basically we aim to this work is only on English. So we want to incorporate more Indic languages. So now I will show you how we have done. We extended this work for the code mixed languages, and also like currently we have already only incorporated the four disorder types like ENT, eye, limb, and skin. Like we want to incorporate, we want to extend this for more other kind of symptoms. And also now the work can only incorporate the images and the text, but we want to incorporate other modalities like video also. So this is our next work, ECIR 2024, where what we have done is that we extended the work in the code mixed Hindi English, and we have also proposed a new data set. So this is our, in order to convert the healthcare magic dataset into code mixed Hindi English, we have used the, yes, again, the prompting technique. So we have given this prompt to ChatGPT. You are a linguistic expert whose task is to convert the English passages into corresponding English code mixed one, labeled examples in English, text in English. Given the English passage text, convert it into corresponding English passage shown in the labeled examples. This way we have given a prompt, and by using the prompt we have converted the we have converted the entire data set into code mixed. So this is a few short prompting is used. We have given some examples, and by showing those examples we have asked it to convert the entire data set from English to code mixed, and the code mix ratio is 30.5. So this is an example of our dataset. You can see like in English, hi and thank you for your time. My 16-year-old daughter has formed some lumps or growths under her skin on her lower legs. They just appeared 3 to 4 weeks ago, starting with one lump on her right calf. She now has three lumps right calf, one large lump on right foot. Doctor, you can give a look at patient, some issue in my legs below and two new lumps on her left calf. Ultrasound was inconclusive and they have scheduled a surgical biopsy for 10/8. Lumps continue to get larger each day. I am just seeking a possible explanation or explanations to ease our mind. Thank you again. Now this is a code mix फैशन. हाय एंड थैंक यू फॉर योर टाइम. मेरी 16 साल की बेटी के लोअर लेग्स के नीचे, उनके स्किन के नीचे कुछ ग्रंथ या वृद्धियां बन गई है. इनकी शुरुआत 3 से 4 हफ्ते पहले हुई, स्टार्टिंग विथ वन लैम्प राइट कल पर. अब उससे 3 ग्रंथ राइट कल पर, वन लार्ज लैम्प राइट फुट पर और 2 नए ग्रंथ लेफ्ट कल पर है. अल्ट्रासाउंड इनकंक्लूसिव था और 10/8 को उन्होंने सर्जिकल बायोप्सी का शेड्यूल बना दिया है. ग्रंथ रोज बढ़ती जा रही है. मैं सिर्फ उसकी मानसिक शांति के लिए एक संभव व्याख्या या व्याख्याओं की तलाश कर रहा हूँ. फिर से धन्यवाद. So this is a code mix version, but the summary is always written in English because our assumption is that summary will be read by the doctors. So what are the possible explanations for the sudden appearance and continuous growth of lumps on a 16-year-old's legs? The image here shows a medical condition, uh, medical continuous growth lumps on a 16-year-old's legs. The image here shows 1 minute. Is it visible now?
Yes, yes, ma'am. Visible. It's visible,
Okay.
ma'am.
Yeah. So summaries, what are the possible explanations for the sudden appearance and continuous growth of lumps on a 16-year-old's legs? The image here shows a medical condition related to foot swelling. The foot is swollen with some redness. So so basically, what we want to do is that we want to obviously initially we tried using the previous clip center like pipeline structure, but that was not working fine for the English data. So basically we failed the necessity of fine tuning the model because somehow the that pipeline based architecture was not working fine with the English data set. So we combine with the, you know, so wanted to combine the visual encoders with the LLMs and then parameter efficient fine tuning using the QLoRa. So this is the model architecture. So we have extracted some image-based encoding from the VIT and also the from the LLM from the text side we generated some LLM-based encoding. We concatenated the embeddings and then passed through the LLM like large language model and then there is a QLoRa based adapter. This QLoRa based adapter is basically fine-tuned using the data set. Okay. So VIT, we have extracted some image-based encoding from the using the VIT, and also the LLM-based encoding are generated from the text, and then we concatenated them and we passed it through the LLM, and we basically fine-tune the LLM by the QLoRa-based adapter, and we generated the summary in English. So this is our proposed model. And these are the results using various LLMs, Llama 2, Mistral, Ficuna, Flantify, Zephyr. Various LLMs are being used. And mostly you can see that Llama 2 is giving us the best blue score. And also the Llama 2 is giving us the best user score. So so these are the results. Also, you can see that Mistral is giving us, this red portions are means the hallucinations. That but the Mistral is giving us less hallucinated output. I think I need to stop now. So so in future we want to incorporate more severity information in the generated summary. And also, as I mentioned, that we have already worked with the image and the text. But in future, we want to incorporate the video also. And also, we want to incorporate some more medical conditions because currently there are only 4 medical conditions: ENT, eye, limb, and skin. But we want to incorporate some more medical conditions and maybe more languages, like only it is applicable for English and Hindi English code mixed. So anyway, these two works are the first to work on the multimodal medical question summarization in healthcare. And we also curated two data sets. One is the multimodal medical question summarization data set and the multimodal medical question summarization data set in code mix format. And we proposed two model. One is a pipeline based approach and that is basically a fine tuning based approach because the pipeline based approach was not working for the Hindi English data set. So so am I running out of time or we have time? We have some time.
Yeah, we have 10 minutes time, ma'am. Can take few questions also. From
Yeah,
the participants if they have.
yeah. Yes. Yeah. So participants, if you have any questions, please ask.
So,
No question.
So I think one question. Okay, okay, that was answered. I think.
Yeah,
Yeah.
yeah. Yes.
Any other questions? Participants, if you have. No, ma'am. I think there are no questions from the participant side.
Okay. Okay then.
Yeah, I do not see any queries in the chat box.
Okay then. Sure. No worries. Thank you. Thank you, Deepak. Dr.
Sure.
Deepak,
Thank you.
for
Thank you,
giving
ma'am,
me this
for presenting
opportunity.
us. Thank you, ma'am. Thank you, ma'am, for sharing your insights on LLM and its uses in the medical imaging domain. I hope participants have at least got idea how to use LLM